Okay, we learn a a fun term here, coterminal angles. So what are coterminal angles? Let's define that first. Coterminal angles. So coterminal. So they both terminate in the same place. In other words, coterminal angles have the same terminal ending side. They terminate in the same place, okay? So let's see some examples of this. Find, how about this? Let's do this. Yeah, we'll go ahead and say find an angle coterminal with 100 degrees. Okay, so we're working in degrees here. So we'll do all of our work in degrees. So the first thing I'm going to do, you're going to find that when you work with angles in trigonometry at the beginning, you're going to draw a lot of pictures, okay? So 100 degrees, we're going to start at 0 degrees and rotate in the positive direction 100 degrees, which is just past 90. So a terminal side is right there. So another angle that could be coterminal is any other angle that lands at the same terminal side. So one way I could do that is I could start at 0 and rotate in the negative direction. So the question is, how much rotation is that? Well, if this is 100 degrees, then this guy has to be, the rest of the revolution, which is altogether would be 360. So the green one has to be 260, but it's negative. Okay? So this is a negative 260 degree angle. That's coterminal with 100 degrees. But there are many answers to this question. Another angle would be to start at 0, rotate to the terminal side, but don't stop. If I did, that would only be 100 degrees. And of course 100 degrees is coterminal with itself. So let's keep going and come back around to this guy. So what angle would that be? That would be 100 degrees plus another full revolution, right? We went to 100 and then we went a full revolution to come back, so that'd be plus 360 degrees to get 460 degrees. That's another angle that is coterminal. In fact, we could change these instructions if we want now. Find angles coterminal with 100 degrees if you want to modify the instructions there, because we found more than one. Here's a negative angle, here's a positive angle. We could keep going, right? For example, if I wanted to work with more negatives, I could rotate another 360 in the negative, so I could subtract 360 from this guy and get negative 620 degrees, okay? So there are lots of angles by simply adding or subtracting 360 degrees that will give me a coterminal, or give me the same terminal side as 100. Alright, let's do another. Let's work in radians now. Find angles coterminal with 2 pi over 3. And we're not going to do anything in degrees here. So the first thing I need to do is locate 2 pi over 3. So I'm going to take pi, the top half of my plane, and I'm going to cut it into 3 equal pieces. So I'll cut here, here, and here. So 2 pi over 3 is right there. Let's go ahead and cut the entire plane into pi over 3's, right? So everything in red. So pi over 3's are tricky because they're the one common angle that doesn't cut at the y-axis. So don't mistake the y-axis as a pi over 3 cut. So 2 pi over 3 is this rotation. Okay, so we've already used that. So what's another angle? Well, we could go in the negative direction. And in some ways, this is easier than degrees because you literally can count. You've got negative 1, 2, see, I counted the y-axis, my mistake. Negative 1 pi over 3, negative 2, negative 3, negative 4 pi over 3 would be that angle. So negative 4 pi over 3 is coterminal with positive 2 pi over 3. Another angle would be to rotate in the positive direction. I could rotate to 2 pi over 3 and then keep going. So that's 2 pi over 3, 3, 4, 5, 6, 7, 8 pi over 3 is also coterminal. Okay? So I could find many more now, but really all you're doing is every time you make a full revolution, you're adding 6 pi over 3's, right? You could take, so how did we get the 8 pi over 3? We took 2 pi over 3, we rotated that, and then how many more pi over 3's are there for a full revolution? Well, that's 6 pi over 3's. There's 6 pi over 3's in a full revolution, which by the way is the same thing as 2 pi, right? 6 pi over 3 reduces to 2 pi, which is literally a full revolution of the circle. But if you add 2 pi over 3 and 6 pi over 3, you get 8 pi over 3. So in either case, degrees or radians, you simply add or subtract a full revolution. So in radians, if I want to subtract a full revolution, I could subtract 6 pi over 3 because that's 2 pi. And that gives me my negative 4 pi over 3 that we got right there. Okay? So that's how you find angles coterminal. Now let's look at a different type of example with the same concept. And this is very common. So let's say find an angle in the interval from 0 to 2 pi. So this means an angle that's between 0 and 2 pi. The bracket means it could equal 0, and the parenthesis means it can't equal 2 pi. Okay, so find an angle in this. In other words, within one positive revolution. Angles in one revolution in the positive direction are between 0 and 2 pi. Okay, find an angle in here coterminal with, let's say, negative 19 pi over 4. Okay, so how do you do this? So you could certainly come to your plane. You could mark out all the pi over 4's, which are, remember, like this. They're equal, they're halfway points between each quadrant. And you could start at 0 and you could literally count negative 19 of those to find your terminal side. Okay? But rather than do that, I really like this technique. Negative 19 fourths. Let's just look at that for a moment. As a mixed number, that's the same thing as negative. How many times does 4 go into 19? It goes in 4 times, with 3 fourths left over. So if we think of negative 19 fourths pi, which is what this is, negative 19 fourths pi, that's the same thing as negative 4 and 3 fourths pi. So all we have to do to locate negative 19 pi over 4 is go to negative 4 pi, which is even. So negative 4 pi, we know since it's an even pi, is over here on the right. And then I need to go, so I go to negative 4 pi, and then I subtract another 3 fourths pi, because this is negative 4 and 3 fourths. So I've got negative 4, negative 3 fourths pi. So here's negative 4 pi, but then I go in the negative direction, 1, 2, 3, and my terminal side is right here. So here's negative 19 pi over 4. Now the path to get there is the negative direction. This angle is certainly, this angle, negative 19 pi over 4, or negative 4 and 3 fourths pi, is certainly not between 0 and 2 pi. So how do I get an angle between 0 and 2 pi? Well, I think of this as 0 and I rotate in the positive direction to get to that terminal side. And I find out what that angle is. So in this case, it's 1, 2, 3, 4, 5 pi over 4. 5 pi over 4 is the same thing as 1 and 1 fourth pi, which is certainly bigger than 0. 1 and 1 fourth is less than 2. So this angle, 5 fourths pi, is between 0 and 2 pi, and it's coterminal with negative 19 pi over 4.